Section 14.4, hyperbolas. So suppose I have 2 points in the plane. I'll call them foci. So I have these two focus. And so the locus of all points whose differences to these two foci are the same is called a hyperbola. Okay, draw that a little bit better. Okay, there. And so this is my hyperbola. So if I take a line passing through these two foci, that is called the real axis or the focal axis. If I take the midpoint between the two foci, that's called the center. If I take a line perpendicular to the real axis, that'll be called the imaginary axis. If I take the intersection of the hyperbola with these real axis, these are called vertices. And if I actually take, it's called the bounding rectangle, and so there's something called a bounding rectangle. And if I take the diagonals of those two, of the bounding rectangle, then this is called, these are the asymptotes. Oops, the other ones are an asymptote. Okay, and well, the that's what a hyperbola looks like. So let's try to determine, I guess, the equation of a hyperbola. So again, if you recall, it is the locus of all points whose difference of distances are the same and between that point and the two foci. So if I take any point on the hyperbola and look at the distance to each of the foci, then look at the difference of these distances and take any other point on the hyperbola, I don't care, maybe over here, and look at the difference of these distances, then these differences will be the same. That's a little much for a little diagram, but okay, so let me try to find the equation for hyperbola. Okay, so let me first just suppose that the hyperbola is such that relative to some coordinate axes, the center is at the origin. And suppose it looks something like this. Okay. And so suppose we have some hyperbola. Okay, so here's my hyperbola. Suppose I have some point here, x, y. And suppose I have, so here's my center, is at the origin. Suppose that my foci are at 0, negative c, 0, c. So those are my two foci. And so if I take this distance here, and this distance, let's say d1, d2, then the difference of the distances is going to be always the same. So suppose that we have a point here, 0b, then this distance here is going to be b plus c, whereas this distance here is going to be c minus b. I'm assuming here that c is greater than 0, just so that it looks nice here. And so the difference of the two distances is going to be, well, b plus c minus c minus b. And so that's going to equal 2b. Okay. So, and here I'm assuming that b is also greater than 0. Again, that's, we can, once I've actually determined these stipulations will actually go away because I'm going to be squaring things, and so the signs will actually disappear. So it really doesn't matter. Okay, so let's figure out the distance here. From the point xy to the point 0b, what's the square root of x minus 0 squared plus y minus b squared, y minus c squared. Next, d2 is equal to the square root of, well, this will equal um, x minus 0 plus y minus the negative c, so y plus c. So let's do the difference of these. And so the difference of these two, oh, and I don't care, maybe I'll say square root of x squared plus y plus c squared minus the square root of x squared plus y minus c squared equals 2b. In reality, actually, I should have absolute values here. Uh, in which case, then my stipulations about them being positive really doesn't matter. So actually, I can absorb all that by just saying square root of x squared plus y plus c squared minus square root of x squared plus y minus c squared equals plus or minus 2b. Let me bring the radical x squared plus y minus c squared to the other side of my equation. And so I get radical x squared plus y plus c squared is equal to radical x squared plus y minus c squared plus or minus 2b. Let me square both sides of my equation to get rid of the square root. And so you get x squared plus y plus c squared equals, well, x squared plus y minus c squared plus or minus 4b radical. I need more room. X squared plus y minus c squared plus 4b squared. Okay, so I can certainly get rid of the x squares. Subtract x squared from both sides. And let me square the y plus c quantity squared. So by a special product formula, I get y squared plus 2yc plus c squared is equal to y squared minus 2yc plus c squared plus or minus 4b radical x squared plus y minus c squared plus 4b squared. Okay, so subtract y squared, add 2yc, subtract c squared, subtract 4b squared from both sides of my equation. So actually I can move that up a little so it looks a little nicer. And so let me subtract y squared, add 2yc, subtract c squared, subtract 4b squared from both sides of my equation. And so y squares cancel. So you get 4 cy minus 4 b squared equals plus or minus 4b radical x squared plus y minus c squared. Divide by 4. So cy minus b squared equals plus or minus b radical x squared plus y minus c squared. Square both sides of your equation. And so I get c squared y squared minus 2bcy plus b to the fourth is equal to b squared times x squared plus, well, actually, let me multiply this out. So this is y squared minus 2cy plus c squared. And so, finally, all the signs have disappeared. Let me multiply by b squared. So I have c squared y squared minus 2bcy plus b to the fourth equals b squared x squared plus b squared y squared minus 2. Ooh, that's a typo. That's a b squared. 2b squared cy plus b squared c squared. Okay. So let me subtract c squared y squared, add 2b squared cy, subtract b squared c squared. And so the c squared y squared is canceled. 2b squared cy cancels. And so you get b to the 4 minus b squared c squared equals b squared x squared plus b squared minus c squared y squared. The 2b squared cy's cancel. The b squared c squares cancel. Let me factor out b squared. So you get b squared minus c squared. So b squared x squared plus b squared minus c squared y squared. Okay, and so now I'll actually let a squared equals b squared minus c squared. In other words, if you add hmm Okay. A squared plus B squared. That should be the other way around. Okay, so let it equal, sorry, C squared minus B squared. In other words, let A squared plus B squared equals C squared. Okay, so let's do that. And so this means that this is equal to a negative A squared B squared is equal to B squared X squared. And then that'll be a minus A squared Y squared. Since B squared minus C squared equals negative A squared, just multiplying both sides of that equation by negative 1. Oops. And so let me divide by negative A squared B squared. And so the A squared B squares cancel. Let me actually move this down a little bit so it doesn't interfere. And so I get here, the B squares cancel, so you get a negative. So you get a negative X squared over A squared. Negative and negative become positive. The A squares cancel, and so you get Y squared over B squared equals 1. So that is the equation of a hyperbola. Centered at the origin, such that, well, its vertices are at 0b, 0, negative b. And so similarly, if you have, so this is a hyperbola centered at the origin. So we have two cases. So it can either be that it goes up, down, or right, left. And so if you happen to have a hyperbola centered at the origin, and let's say it looks oh boy. Let's see if I can draw this a little bit better. Okay. Then I have that the center is at the origin. This would be B minus B A. The vertices are at plus or minus A, 0. The real axis is the x-axis. The foci are located at C minus c. The asymptotes, the equation of the asymptotes, well, it goes rise over run, so it's y. The equation of your asymptotes, y equals plus or minus b over a x. The equation is just x squared over a squared minus y squared over b squared is 1. And, well, in the other case, which we actually found the equation for, suppose you have so it's a, negative a, b, negative b. So here are my asymptotes. And suppose that your hyperbola looks something like it's like this is like it's off, like I shifted it too much. Let's try this one again. Okay, so oops. So let's see if I can draw this a little bit better. So it still looks a little like I'm good enough. This doesn't look great, but here are my vertices. Here is my center. And here are my foci. So the center is at the origin. Vertices are at plus or minus b. And the asymptote, and the foci, are at 0 plus or minus c. Oh, where of course a squared plus b squared equals c squared. So I have the equation of the asymptotes of y equals plus or minus b over ax, and I have that. Just put this up a little bit, if I can. There. Okay, come on. And I have that a squared plus b squared equals c squared. Okay, so the equation for this asymptote, for this hyperbola, is negative x squared over a squared plus y squared over b squared is equal to 1. Okay? Suppose I have instead a hyperbola but it's centered at the point hk. Then all you're going to have to do is just translate this. Okay, and so the center will be at hk. The vertices will be at, let's do the first one, where they're at h plus or minus ak, and the foci are at h plus or minus ck, and we have that a squared plus b squared equals c squared, and so it'll look virtually the same as, let's say we're doing the x's, so it'll look the same as this. Good. Let's just copy it, paste it, see how it pastes. Okay, not too bad. And then I'll just sort of Okay, good. So now what I can do is just, oops, I have to get rid of, so it doesn't look like there's axes there. Okay, so now uh, let's just say that this is x, y, and this is h, k. And so here's my center. Here's the center. And here are each of the vertices. Here's the center, and here are the foci. So there are the foci, center, and here are the asymptotes. Oh, and the equation of your asymptotes are y minus k equals plus or minus. This is and so plus or minus b over a x minus h. And those are the equations for your asymptotes. Similarly, let's do the other one. So suppose the center is at hk. The vertices are at h, k plus or minus b. The foci, h, k plus or minus c. A squared plus b squared equals c squared. It looks like a Pythagorean theorem. The equation for your asymptotes, y minus k equals plus or minus b over a x minus h. And so it will look like, well, this other one. It'll look like this. I'll copy it because I had hard enough time doing it from before. Oops. So I'll just sort of copy this. Not like it's a great hyperbola, but at least it's something I don't have to draw anymore. So I'll get rid of so it doesn't look like axes anymore. Okay. And so, oops, suppose that the vertex, the center, is at HK. And so here are my asymptotes. This, here are my vertices. Here are my two foci. Here's the center. And I've drawn my bounding rectangle. The distance from the center to this is A, from the center to this vertex is B. Well, the absolute value of A, absolute value of B. Or assuming A and B are positive. And the distance from the center to the focus is absolute value C. Okay, so that's in general what the equations of the hyperbolas look like. So I guess where do you see them? And so hyperbolas. Okay, so first Well, let's see. If you happen to have, let's say that this is the sun, and you happen to have a comet. Comets could travel along a hyperbolic curve. Most of them actually, so any sort of body that could come in, there are some types of bodies that come in where they only travel past the sun once. Uh, and so those sorts of objects that only come by the sun once, they could go along a hyperbolic curve. Most comets, well, many comets actually go in elliptical curves because they'll come back. Uh, Next, suppose you are looking in in some sort of telescope. There, so some sort of telescope. And well, what you'll notice is that in your telescope, you will have actually two mirrors. So one mirror will be a hyperbolic mirror. And the other will be a parabolic mirror. And so all your light from your stars will come in. And then they'll focus in on your eyes. Okay? And so many sort of telescopes work in that fashion. Okay, and then you'll have usually an extra lens there. But okay, let's do some examples, I guess. On page 615. Let me do problem number 2. X squared over 25 minus y squared over 4 equals 1. So notice that if you look at a hyperbola, it more or less looks like the same as an ellipse. The only difference is an ellipse, well, you're always adding the squares. But here you add one and subtract the other. So basically what we've done is we have made one of these variables imaginary. And so what we've done is we've put an ellipse in the complex plane. Once you've done that, then it becomes what's called a hyperbola. So actually, that's why we call this focal axis the real axis, and this other one the imaginary axis. And so what we've basically done is we've taken this ellipse that usually is within this bounding rectangle here, and we've blown it up so it now is in the complex plane. Okay, so let me do problem number 2. Graph the equation given standard form, give the length of the real axis. Okay, so let me do that. And so, in this case, I always take A as being the number under the x. Well, the square root of 25 is 5. B, the number under y, the square root of 4 is 2. C, 25 plus 4 is 29. So C squared is 29. So C is equal to the square root of 29. The center of my hyperbola is going to be at the origin. The equation of my asymptote is just y equals plus or minus, well, b over a, 2 over 5x. So let's graph this. And so we're centered at the origin. So we go out 5 and x. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We go out 2 in y. 1, 2, 1, 2. Let's draw the bounding rectangle. Okay, now let's draw the diagonals, which will turn out to be the asymptotes for my, okay, good enough. It's not very straight, but as good as I can get it. So I've drawn the bounding rectangle here. The diagonals of my bounding rectangle are my asymptotes with these equations. And so now, notice that there's a plus in front of the x squared. So therefore, my real axis will be the x-axis. And so my vertices will be located here. And I'm going to approach each of these asymptotes, go through the vertex. That's not good at all. Okay, let's try again. It's harder on this side. So let's try this. uh, as I get closer to this edge, it's harder and harder to. Okay, forget this. Let me just sort of do an arrow. See, I was able to do an arrow. Okay, there are quite a few limitations on the drawing on this tablet. One of them is going towards the edge. Okay, so um, so those are my asymptotes. So here are my vertices. Here's my center. Here are my asymptotes. And my vertices, square root of 29 is a little bit bigger than 5, but less than 6. So probably about here are my foci. Okay, and that's your answer. That's what the graph looks like. Let me do problem number 12. (16) y squared minus x squared equals 64. Okay. So in exercises 7 through 18, write the equation standard form and sketch the graph. Oops, I forgot to give the length of the real axis. So the length of the real axis so that's the distance between the, oh, I didn't write the, you know what, I just said ABC, but I didn't write, and I said the asymptote, but I didn't say what the where the vertices were. So the vertices are at plus or minus 5, 0. The foci are at plus or minus rad 29, 0. The other 2 points, which I really sort of consider vertices, are here at 0 plus or minus 2. So the distance between the 2 vertices, well, 5 plus 5 is 10. And that's the length of the real axis. Okay, I keep forgetting that. Okay, so let me do problem number 12. So first off, let me divide both sides of my equation by 64. And so you get, and I'll write the x squared first. So I get a negative x squared over 64 plus y squared. 64 divided by 16 is 4, is equal to 1. Okay, so now it's in standard form. And so in this case, the center is at the origin. A is equal to 8. B, square root of 64 is 8. Square root of 4 is 2. C, 64 plus 4 is 68. And so this is just, not that it really matters. 4 times 17 is 68. And so this is really just 2 rad 17. The equation for the asymptotes are, well, y equal plus or minus b over a, 2 over 8, 1/4 x. The vertices are, well, let's see. The square is in front of the y. The positive is in front of the y squared. Since the positive in front of y squared, so it'll be the y. So 0 plus or minus 2. The foci are going to be at 0 plus or minus 2 rad 17. And we have the asymptotes. What else did I want? The real axis. And so let's figure out the distance to the real axis. Well, 2 plus 2 is 4. So the real axis has a length of 4. So let's draw this. And so let's see, 8. And the other one is 2. Oh, 8's going to be a long way. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 4, 5, 6, 7, 8. 1, 2, 1, 2. Okay, that's not too horribly bad. It's still going to be very flat. Okay, so I think I did the. Oh no, I did it in black and then red. Okay, I think I'll still do this in red instead. So let me do the bounding rectangle. So this is what my bounding rectangle looks like. Okay, and let me draw the diagonals. Oh, those are going to be really flat. This is a very, very flat. Oh, maybe even more so than that. This is a very flat hyperbola. Okay, and so let me see if I can draw this. Oh, this is going to look like nothing. This is very flat. Okay, and here are the vertices. Here are the center. So center, vertices, foci, 2. So that's the square root of 68. Let's see. So 68, 8. Is it really 8? Oh, that's just too far. 1, 2, 1, 3, 4, 5, 6. Oh, it's way up here. Okay, so um, those are your foci are way the heck out there. Yeah, your foci is a way away. I guess maybe that's why it's so flat. You have gigantic foci compared to your vertices, so they're a long distance from your vertices. And that's your answer. Did I write the? Yeah. Oh, here up here is the equation of your asymptotes, which again is very flat also. Okay, good. And did I find the length of the real axis? The length of the real axis is 4. So notice that the real axis is fairly tiny, the length of the real axis. Okay. So, oh, and maybe I should say that just so that in case you. So to figure out what C is, so notice that A squared plus B squared equals C squared. And so 8 squared plus B squared is C squared. 64 plus 4. So that's how I get the 64 plus 4 is 68. And so that's how I get 2 rad 17. Next, how do I get the equation for the asymptotes? Well, it's just rise over run. And well, if I look at this point here, well, the rise is, well, 2. And the run, how far you've gone, is, well, 8. So that's 1 over 4. And, well, the other way, it's going to be negative 2 over 8. And so you get a negative 1/4. And so that's why you get the equation of asymptotes as being, and of course you go through the origin. So that's why you get the equation of asymptotes as being y equal plus or minus 1/4 x. Okay. Let me do problem number 18. And so let me do 18. Y minus 2 squared over 9 minus x plus 3 squared over 4 equals 1. Okay. So let's do this. So I have here, oh, and let me just write it, the x's first, I guess. X plus 3 squared over 4 plus y minus 2 squared over 9 equals 1. So in this case, A, square root of 4 is 2. B, square root of 9 is 3. C, 4 plus 9 is 13, so C is equal to radical 13. The equation of your, oh, and your center is at negative 3, positive 2. The equation of your asymptotes is just y minus 2 equals plus or minus b over a, 3 over 2 times x plus 3. So I have y minus 2 equals plus or minus 3 over 2 times y plus 3. The vertices are at, well, since the plus is in front of the y term, and so we're going to be adding and subtracting to the y coordinate. And so negative 3, 2 plus or minus 3, which I should write as negative 3, negative 1, negative 3, positive 5. So those are my vertices. The foci are located at negative 3, 2 plus or minus rad 13. You can't really simplify that because you don't know what the square root of 13 is equal to exactly. I think that's it. Oh, the length of the real axis. And so the real axis, well, that's going to be along the y, and so that'll be the b. So 2 times b is equal to 6. Okay, so let's do this. So x, it is a little difficult on that end. Y, and so let's see, the center is at -3, +2, and a is 2. So we'll go 2 in the x direction, 2 in the, and 3 in the y direction. 1, 2, 3, 1, 2, 3. So it should look something like, well, let's start here. Okay, and let's do the diagonals, which will give us our asymptotes. Close enough. Not really very good, but close enough. And so this is going to be y, because the plus is in front of the y squared. Okay, so it should look something like here are my vertices and my foci. So square root of 13 less than 4, so 6. 1, 2, 3, 4. So somewhere around here. Okay. And so it should look something like, let's see if I can do this. Should be near the asymptotes. Go through there. Keep going. Approach the asymptote. Not bad, actually. Let's see if I can do this one. Near the asymptote. Approach that. Keep going towards the asymptote. Okay. And so here are my foci. Here are my vertices. Here's my center. And here are my asymptotes. Okay. And that's it. So please note that you go 1, 2 in your x direction because a is 2. You go 1, 2, 3 in your y direction because b is 3. And you go that from the center, which is found by changing the sign, -3, +2. And your foci are in the y direction because, well, there's a plus in front of the y. Okay. Let me do. Let's see, did I get everything? I think so. Let me do number 24. It exercises 24. In exercises 19 through 27, use completing the square method to convert the equation to standard form. Use the extended diagonals of the fundamental rectangle to sketch the graph. 9x squared minus 4y squared minus 18x plus 16y is equal to 43. Okay, so let me do that. So first, let me group x's together. 9x squared minus 18x minus 4y squared plus 16y equals 43. And so let me group the x's and y's together. And so that I can factor out a 9 from the x's. So I have a 9x squared minus 2x. I can factor out a negative 4 from the y's. So negative 4, y squared minus 4y equals 43. And so now let me complete the square. And so since there's a 1 in front of the square, negative 2 divided by 2 is negative 1 squared is 1 times 9 is 9. Since there's a 1 in front of the y squared, negative 4 divided by 2 is negative 2 squared is 4 times 4, negative 4 is negative 16. And so I get 9 times x minus 1 quantity squared minus 4 times y minus 2 quantity squared equals 36. Divide both sides of my equation by 36. And so I get x minus 1 squared over 4, y minus 2 squared over 9 is equal to 1. And so the center of my hyperbola is at the point 1, 2. A, the square root of 4 is 2. B, the square root of 9 is 3. C, 4 plus 9 is 13. So C is equal to radical 13. Let's determine the equation of my asymptote. And so y minus 2 is equal to plus or minus b over a, 3 over 2, x minus 1. And so that's the equation of my asymptote. Let's determine the vertices. And so the vertices will be at 1, at 1. Again, there's a plus in front of the x squared, so it's plus or minus 2. And so this is going to be 1 minus 2, negative 1, 2. 1 plus 2, 3, 2. The foci are located at 1 plus or minus rad 13, 2. Okay. And that is your, those are your foci. And so, did they ask for the length? Oh, they finally didn't ask for the length of the real axis, so I won't do that. And so let's draw this. X, Y. So the center is at 1, 2. Let me go 2 in the X, 3 in the Y, 1, 2, 3. Let me draw my bounding rectangle. let me draw the, oh, and it's at 1, 2, so my center. Let me draw my diagonals. Which will be my asymptotes. Uh-oh. So let me try this again. Okay. Okay, so let's try this again. Let's see if I can do it. Should not skip around too much. Okay, not too bad. And it's the X. And so that's going to be here, here. So here's my center. Here are my two vertices. And it's 1 plus square root of 13 is a little over 3 less than 4. So it should be about here. Here are my foci. And so let me draw my hyperbola. Okay, let's try this again. Why it keeps going off when I get close to that. Okay. Let's see if I can start here. Huh, even there it veered off. Okay, let's try this again. See if the pen will actually draw where I point to. No, of course not. It is veering off as I draw it. Well, I'll just... Okay, so good enough. The pen is not being very nice today. So that's those are my hyperbolas. Here are my two asymptotes, the center, vertices, and foci. Let me do, let's say problem number 30. So problem 30 is in exercises, '28 through 34, determine the foci of the hyperbola. And so, x squared over 9 minus y squared over 16 is equal to 1. And so let's figure out the foci. And so the center is at the origin. So in this case, I'll just give you a general sort of idea of what it's going to look like. But don't take this as being anywhere accurate. So I have some sort of hyperbola that looks something like this. And here are my center, vertices, and foci. Okay. So A in this case, square root of 9 is 3. B in this case, square root of 16 is 4. C, 9 plus 16 is 25. Square root of 25 is 5. Therefore, the foci are located at plus or minus. Again, this is going to be, since the plus is in front of the x, it'll be plus or minus 5, 0. Those are my two foci. Let me do problem number, let's say 35. And so, in problem 35, the vertices are at plus or minus 3, 0, and the foci are at plus or minus 5, 0. In exercises 35 through 41, find the equation of the hyperbola satisfying the given conditions. Well, since the vertices are at plus or minus 3, 0, foci plus or minus 5, 0, the center is going to be at the midpoint between the vertices, midpoint between the foci, so 0, 0. So if you notice, we have the vertices are at 3, negative 3, and so you have some sort of, I don't know how high this other one goes, but I'll just assume it looks something like this. And you have your foci here. So you have vertices, foci. And your hyperbola is going to look something like this. Very crudely, something like that. And so the center is going to be the midpoint between these two vertices, which turns out to be, well, the midpoint between, plus 3 and minus 3 is going to be 0. Therefore, the equation is going to look like x squared over a squared minus y squared over b squared is 1. The real axis will just be the x-axis. And so, in this case, I know that a is 3 because, well, the vertices are at 3, 0. I don't know b yet, but I know that c is equal to 5. So now the question is, well, what is b? Well, a squared plus b squared equals c squared. And so 9 plus b squared is 25. Subtract 9 from both sides of your equation. So b squared is 16. And so from that I get the equation for my hyperbola is x squared over a squared minus y squared over b squared is equal to 1. And that is the equation of my hyperbola. Okay. So let me give you some general facts about quadratics. Oh, wait. I can do that before let me do, let's say, so last one we did is 35. Let me do problem number, let's do one or two more of these before I go on. So maybe problem number 40. Yeah, we'll do problem 40. And so the foci are located at plus or minus 10, 0. And the real axis is 16 units. Okay. Well, that says that, well, a is half of that, 8. So let's see why that's true. So the foci are at 10. plus or minus 10, 0. So they're along the x-axis. Now the real axis, they said, has a length of 16. So therefore, the distance between the two vertices is 16. Since the midpoint between the foci is the center, then by symmetry, we must go 8 positive and 8 in the negative direction from C. So A is equal to 8. Let's figure out what B is. Well, I don't know what B is. Let's figure out what C is. Well, C is just the distance from the center to the foci, which they tell me is 10. And so, this is the same problem as above. Let's do the fact that a squared plus b squared equals c squared. Pythagorean's theorem. And so 8 squared plus b squared equals c squared. Subtract 64 from both sides. So b squared is 36. And so I'm done. Oh, I should have said this first. Note that the equation of my hyperbola is x squared over a squared plus minus y squared over b squared is 1. The reason for the minus in front of the y is because the reason for the plus in front of the x squared is because the focal axis, the real axis, is along the x-axis. And so, well, I know what a squared is. It's 64. I know what b squared is. It says that it's 36. And so that is the equation of my hyperbola. Let me do problem number 44. 4x squared minus 9y plus 2 squared equals 36. Divide both sides of my equation by 36. And so I get x squared over 9 minus y plus 2 squared over 4 is equal to 1. Okay, so the center in this case is 0, negative 2. A is 3. B is 2. 9 plus 4 is 13, so C is equal to rad 13. And so my vertices are at 0 plus or minus 3, so 3, negative 2, and positive 3, negative 2. The foci are located at 0 plus or minus rad 13, negative 2. The asymptotes are located at y plus 2 equals plus or minus b over a x. Maybe I'll write it as y equals a negative 2 plus or minus 2/3 x. Just because it looks a little nicer. Not that it's any better, but okay, so that's the equation of my asymptote. Find the center. Find the center. Done. Vertices. Done. Foci. Done. And asymptotes of the hyperbola. Done. And sketch the graph. So let's sketch the graph. Okay. And so the center is at 0, negative 2. And we are at 1, 2, 3, 1, 2, 3. Okay, you go 2, 1, 2. Okay, so let's do this. Okay, and let me draw my asymptotes. Draw this. Okay, and the plus is in front of the x. Okay, so let's draw this. Let's try this. Okay, good enough. Good enough. So those are the. Yeah. Okay. Good enough. Okay, so those are my. That's a graph of my hyperbola. So I have here my asymptotes. I have here my vertices, my center, and the foci, radical 13. So that's we're out there. You're out there. Okay. Good. So let me do the following. So I'm actually going to classify some solutions to these following. So quadratic curves in two variables. Hmm. And so um, if I look at a quadratic equation in two variables, so let's look at a quadratic equation in two variables, x squared plus b xy plus c y squared plus dx plus ey plus f equals 0. Okay? And so let me assume that um, it is, we have non-degenerate solutions. And so there are going to be a few degenerate solutions, and we don't want to look at those, consider those, because it'll make the statement of this much, much more complicated. And so, meaning I don't want an empty set, nor do I want a point, nor do I want. This pen is having so much trouble today. Nor do I want uh, a line, nor do I want two lines. So there are cases where we could get an empty set as a solution to this equation, or a point, or a line, or two lines as solutions, but I don't want those. Let me let d equal b squared minus 4ac. Then, if d is 0, it turns out that the solution of this is a parabola. Okay? If, in fact, b is 0, then either a is 0 or c is 0. And so if I have the case where, well, I don't have this term here, the xy term, then the only way that I can have a parabola is that one of the square terms is non-existent. Next, let's look at the case that the discriminant here is greater than 0. In that case, we have a hyperbola. Okay. Now let's consider the case where again b is 0. So if this b is 0 here, then that just says that AC has got to be greater than 0. Then the sign of AC, that has got to be greater than 0. So the minus 4AC has got to be greater than 0. So AC has got to be less than 0 in the sign of it. Okay, so if b is 0, then if the signs of the squares are different, then we have a hyperbola. Okay, so let me just assume that b is 0. So in the first case, if we only have one square term, then it's a parabola. If the signs differ, then we have a hyperbola. Let's look at the third case. If the discriminant is less than 0, then we have the case of an ellipse. Okay. If again I look at the case where this xy term is 0, then if the sign of A and C are the same, they're both positive or both negative, then we have an ellipse. Okay. So if this middle term here, this b is 0, if I have no xy term, then if one of the square terms is missing, parabola. If the signs are the same, ellipse. If the signs are different for the squares, hyperbola. In addition, if not only is the xy term 0, but if the reason that the signs are the same is because they're actually the same numbers, then this will be a very special ellipse. It'll be a circle. So if this term is 0, the xy term is 0. If one of the square terms is missing, parabola. If, again, assuming that the xy term is not there, if the signs of the square terms are different, hyperbola. If the signs of the square terms are the same, it's a ellipse. If not only are the signs the same, but they're actually the same number, then it's a circle. Okay. And by the way, this term b here, if it's not 0, what it does is it actually rotates the curve. So this is sort of a rotation. And so let me do um, problem number, let's say 51. And so 4x squared plus 4y squared equals 36. In exercises 51 through 58, identify whether the graph of the equation is a circle, an ellipse, or a hyperbola. Well, since the discriminant is equal to, well, 0 squared minus 4 times 4 times 4 is negative, then this is an ellipse. And since b is 0, and since a is equal to c, 4 is equal to 4, then this is a very special type of ellipse. It is a circle. Let me do problem number 54. Nine x squared plus y squared equals 18. Okay, so let's do that. And so the discriminant, b squared minus 4ac, is equal to, well, b is 0. A is 9. C is 1. And so my discriminant is equal to a negative 36, which is less than 0. And so this is an ellipse. In this case, it's not a circle because, well, A is not equal to B. Let me do problem number 56. And so 5x squared minus 4y squared equals 60. And so the discriminant, b squared minus 4ac, is, well, b again is 0, a is 5, c is negative 4, and so my discriminant is a positive times negative is positive 80. And so this is a hyperbola. Notice we have the following. Since the numbers in front of x squared and y squared are the same, circle. Since the numbers in front of x squared and y squared have the same sign, ellipse. Since the numbers in front of x squared and y squared have different signs, it's a hyperbola. Let me do problem number 58. Four y squared minus 6x plus 8y is 13. And so my discriminant is equal to b squared minus 4ac, which in this case is 0, minus 4a is 0, c is 4, and so my discriminant is 0. And so that says that this is a parabola. And so notice that I only have one square term, Therefore, it is a parabola. Let me do problem number 50. xy equal -4. Here it says to sketch the graph, and exercises 48 through 50 sketch the graph. But actually, I'm going to identify whether it's a circle, ellipse, or hyperbola first. And so d equals b squared minus 4ac. Well, b in this case is 1. A is 0. There's no square term in front of the x. There's no x squared term. And c is 0 because there's no y squared term. And so d is equal to 1, which is greater than 0. Oh, and so this is going to be, well, a hyperbola. So we have a hyperbola. So the graph of that looks like a hyperbola. Okay, so, well, let's see. Let's sketch a graph of it. Notice that if I divide here by x, I have y equals a -4 over x. And so I can sketch this. So basically, this looks like a reflection of y equal 4 over x. And this will be about the x-axis. Well, reflection of y equal 4 over x about x-axis. And then this is the scaling. You're going to stretch the y-axis by a factor of 4 for y equal 1 over x. So if I look at the graph of 1 over x, it looks something like this. I'm going to stretch by a factor of 4. So it's going to be steeper. Well, it's going to be hard to show that. It's going to be even steeper than what it is currently. So even more so. Okay, so something like that. Oops, what happened there? Sorry. Will you stop that? Okay, hopefully you can still hear me. Okay, so this was first the graph of y equal 1 over x, and then I stretched it by a factor of 4 to the graph of y equal 4 over x, and then let's reflect. And so I get, looking like this. So this is the graph of y equal a -4 over x. But now if you notice, I have a horizontal asymptote. Of the x-axis. and I have a vertical asymptote of being the y-axis. And so this just looks like what we've been drawing before. It just looks like the graph of, the uh, this sort of asymptote where all I've done is I've just rotated it 45 degrees. Let me see what this is. It's saying it stopped sharing. Okay, let's stop. Sorry. Let me start sharing yet again. Okay, is it sharing now? Sorry about that. Sometimes it has a mind of its own for a second. Hopefully. Yay. Okay, sorry about that. It just sometimes does stuff like that. Okay, so that is actually the end of. Yeah, that's really the end of. Yeah. So that's the end of section 14.4. Let me stop this for. Let me